Excellent. Thank you everyone so much for joining. We'll wait a few more moments so folks could keep joining the webinar link. Excellent. Thank you so much everyone for joining. Good morning, good afternoon, and good evening to everyone joining us today. Welcome to the third session of the Mangrove Breakthrough NDC webinar series. My name is Christina Rodriguez. I'm the Ocean and Coastal Zone Associate with the Climate Champions team, and I'm honored to be moderating today's session on behalf of the Mangrove Breakthrough NDC Task Force. The Mangrove Breakthrough NDC webinar series is designed to equip governments and mangrove practitioners with technical expertise and tools to help translate their endorsements to the Mangrove Breakthrough into specific, measurable, and science-based commitments in their NDCs and related national climate strategies for the conservation, restoration, and management and financing of mangrove ecosystems. Today's webinars, we're going to be introducing a suite of cutting-edge data platforms and research tools that can directly inform and enhance mangrove targets in nationally determined contributions, also known as NDCs. Amongst the tools that we're going to be exploring today, we'll be going over the Global Mangrove Watch, the Coastal Carbon Atlas, National Forest Inventories, and National Mangrove Monitoring Systems, including local-level data collection. These platforms offer spatially explicit, near real-time data on mangrove extent, condition, and locations, helping policymakers, practitioners, and investors to better understand, monitor, and report on mangrove ecosystems. Also, and very importantly, today's session will also showcase real-world application of these tools. We're going to be hearing from 2 country case studies with government representatives from Mexico and Panama to hear how these countries are using these data tools to inform NDCs, as well as how these data tools can align with broader national strategies like NBSAPs, NAPs, and Ramsar commitments. Ultimately, we aim to help you identify the most appropriate tools for your various policy, planning, and investment decisions around mangrove conservation. A few housekeeping notes before we get started. Today's session is scheduled for 90 minutes, and closed captioning is available for accessibility. Please feel free to turn it on if needed. You should see it in the bottom right-hand side of your Zoom link. We'll also reserve time for a question Q&A segment from the audience at the end, but please feel free to start posting your questions in the chat throughout the webinar session. Also, the resources that are referenced today will be shared via email after to participants who are registered. And also, for those who are unable to join us live, we'll be sharing a video recording via YouTube for those that are interested in learning but were unable to join today. So with that, let's go ahead and have a quick look at the agenda. Next slide, please. Thank you so much. So we'll have opening remarks from Emmanuel Pinant, representing the Mangrove Breakthrough Council chair member, and also the director from the Systems Transformation team from the Climate Champions team. After that, we'll move into our mangroves and NDC country case studies, where we're going to be hearing government representatives from Mexico and Panama. And after the country case studies, we'll be moving into the data resource deep dives segment, where we're going to see data tools provided from the Global Mangrove Alliance, the Global Mangrove Watch specifically, as well as the role of research for mangrove data. And this is a resource from the Smithsonian Institution. It's the Coastal Carbon Atlas. And the third and final data resource that we're going to go over is mangrove monitoring for climate change mitigation and its insights from the IPCC Wetlands Supplement and beyond. After that, we'll have closing remarks from Luce Gill, who's the Ocean and Climate Advisor from the Nature Conservancy. And with that, we'll move into the discussion/Q&A audience segment. It's now my great pleasure to invite Emma from the Climate Champions and the Mangrove Breakthrough Council Chair to set the stage and give the opening remarks. Emma, over to you. Thank you so much.
Thank you so much, Christina, and good morning, afternoon, evening, everyone. So my name is Emmanuel Pinot. I'm the Director of Systems Transformation in the Climate Champions team and also a member of the Mangrove Breakthrough Council. I am really happy to be with you today to open this webinar convened by the Mangrove Breakthrough NDC Task Force. To start, I'd like to say just a few words on the Mangrove Breakthrough, which is a global call to action to secure the future of 15 million hectares of mangroves globally by 2030 through collective action by non-state actors and governments on halting mangrove losses, restoring half of recent mangrove losses, doubling the protection of mangroves globally, and, perhaps more importantly, ensuring sustainable long-term finance for all existing mangroves by achieving an investment of $4 billion USD by 2030 to conserve and revitalize this coastal ecosystem. As of today, 37 governments, both national and local and regional governments, have endorsed the Mangrove Breakthrough. And in this year, particularly where countries are making their national determined contribution to the Paris Agreement, there is a huge opportunity for governments who have endorsed the Mangrove Breakthrough to translate this into their NDCs. And this is what this Mangrove Breakthrough NDC Task Force is about. It's an initiative that has been created within the Mangrove Breakthrough Hub by the Pew Charitable Trust, the high-level climate champions, and members of the Global Mangrove Alliances, as well as other local and global mangrove policy and research organizations. The aim of this task force is to provide a space for the mangrove policy and science experts to provide technical advice to countries as they develop their NDCs and help them integrate mangrove and climate adaptation and mitigation benefits for mangrove into their new plans. So today, the NDC Mangrove Breakthrough Task Force is going to present a few new tools that are part of the portfolio of resources available to countries and experts. We are delighted to see this happening. As you know, we are at a turning point in 2025, halfway in the critical decade for climate action, 10 years after the Paris Agreement was adopted. And now, more than ever, it is time for implementation of the great commitments that have been made in previous years. That means concretely shifting financial resources and adopting enabling policy frameworks such as the NDCs, who are part of the most important enablers for systems transformation and honestly a very important way to make the Mangrove Breakthrough a reality. So that's why I'm delighted to be here with you, and I really congratulate you on this effort and this task force, and I wish you a productive session that will help us collectively advance our common goals. Thank you for your attention.
Thank you so much, Emma, for that powerful opening. Your framing really sets the tone for why mangroves are a global climate priority and how the Mangrove Breakthrough is really helping us move from ambition to implementation. Now, let's take a closer look at how countries are doing just that, beginning with Mexico's efforts to develop data-informed mangrove targets. We now turn to our first country case study from Mexico. We're pleased to welcome Edgar Villarda, Head of Remote Sensing at Mexico's Mangrove Monitoring Systems. Edgar will share how Mexico is using mangrove data in its climate commitments. Edgar, over to you. Thank you so much.
Hello, good morning. Can you hear me well?
Yes.
Okay, thank you. Okay, I am, as Cristina says, I'm Edgar Villeda. I'm a biologist. I'm working in Mexican Mangrove Monitoring System in CONABIO, which is the National Commission for Knowledge and Use of Biodiversity. So this is the names of the team. I'm not alone with Well, my team, we work in the next, I will present you. Please, next. Why do we need a mangrove monitoring system? Because we have a lack of understanding and we have a lack of the amount of how much mangroves do we have in Mexico. So we didn't know either the extension and distribution, and we didn't know how much we are losing of that ecosystem and how the human impacts or other impacts are working in the losing. In order to obtain the change rates, identify sites of the main change drivers, generate information about the state of the ecosystem, and obviously apply the law to protect them. So Mexico is the fourth place in coverage area from mangroves. Next, please. So the goal of the Mexican mangrove monitoring system is to identify changes in the ecosystem. So if we identify the changes, we will be able to identify the areas we are losing or in process of degradation, and also to obtain information about the social attributes and obviously the spatial distribution with periodic analysis. We do these maps each 5 years. So this information will support for the conservation and management of the ecosystem. One important thing we want to tell you is that the Mexican mangrove monitoring system is working just in the remote sensing theme. So with remote sensing techniques, we obtain several imagery, satellite imagery, and we build these maps for each 5 years. We will show you. Next, please. So the method is that we first have like a several imagery and aerial photography first, georeferenced aerial photography from the 70s and the 80s. And we build like a mosaic and work with this map. And then we have the spot imagery from the French agency. And we have covering the whole coastal Mexico with several images, about like 200 images. And we start with this. So we built the 2005 next, and 2010 and 2015. Then this spot 5, it's closed, the satellite is closed, and then we are using actually Sentinel-2 imagery. The same is we are looking for a big mosaic of the whole coastal areas in Mexico with a method which is called unsupervised classification. We just have like a baseline, and starting from a baseline, we do an update from other imagery. This method, it's proposed by FAO. So this method minimizes the effect of using different sources in the information we do have, because in Mexico, in some areas in Mexico, it's very difficult to obtain satellite imagery without clouds. So we have to use another kind of imagery. Next, please. Now we are working in the 2025 map. This is more or less the distribution of the mangroves in Mexico. We have a minimum mapping area from 1 hectare. So all the mangroves below these 1 hectares cannot be mapped because it's a national scale map. But we have several like Petri cases in the whole country. So we have reached like the 94 accuracy. So you have 94 accuracy that when we say that it's covering mangrove, we are like 94 accuracy percentage. Next, please. What do we do with this information? Next, please. So in the Mexican mangrove monitoring system, we have like 4 principal components. The main is which I have tell you, the spatial distribution, mangrove extinction, and dynamic change. Then we have one important thing we are working now, the mangrove characterization. So we have the level protection, disturbance level. We analyze the connectivity, distribution of the several species in Mexico, and some and other environmental variables. And one important thing is when you have the mangrove coverage, you have the coastline. So we analyze the coastline dynamics, how we are losing in some parts in northern or south Mexico. We are losing coast. The sea is gaining, and we are losing some mangroves, and in other areas we are gaining with mangroves. So we have in this case the regionalization of the mangroves, and the next step is to have a restoration observatory. The other component in this system is we have analysis of anthropization, which is we have land coverage, and we subdivide the land coverage in anthropic categories. We will see. And we have public policy effects in mangrove conservation. We have some analysis about that and how the human population and economic activities impacts in the near areas of these mangroves in Mexico. And one important thing, it's the interinstitutional collaboration. So Conavio is not working alone. We have experts in directory in the whole country. We have a lot of universities, institutes, collaboration. We have meetings and workshops in order to share the information and reach one objective, which is to get map and all the analysis with help of these whole people. And then we have publications. We have a lot of papers and books, guides, field guides, and obviously all this information is published in the web page and the geoportal of Conavio. It's for free. The following aspects that you will see, we think that can provide information about addressing and advancing of NDCs achievements. Next, please. This is the spatial component. It's an example of how do we do the maps. In red, you see the maps, and we have a 5 kilometers buffer to analyze the whole land use cover. And we have other coverage like urban areas, disturbed mangrove, other wetlands, body waters, agricultural and cattle ranch areas. Next, please. This is a graphic that shows the anthropic dynamics. For example, it is divided by regions, starting at head in Pacific North, and then Center Pacific. The last one is the Yucatan Peninsula. In orange, you can see how aquaculture farms and artificial ponds are impacting or degrading the mangroves. And finally, in Peninsula de Yucatan, you can see how the setting up and building areas and touristic areas, they are damaging or degrading or fragmenting the mangrove. And the next one, please. This is the example of the coastline. How these dynamics in the Mexico map you see on the left. In red you see these triangles, inverted triangles with losses, and the green triangles with gains in coastline. So this is an example in Ciudad de Carmen in Gulf of Mexico. So we just see how across the years we are losing coastline or gaining the mangroves. Next, please. And this is another example of how we can identify this change in the coastline. We have flights with drone and LiDAR information to identify how the slope or how the hydrodynamic of sedimentary soil dynamics are changing in certain areas of Mexico. Next, please. Yes, another component we have, another theme in the component of characterization is that we have identified invasive species. This is an example. This is like a perennial creeper or deciduous bush, which is covering mangrove. You see in the left, upper left, Cissus verticillata is the name, and how this kills the mangrove. And we are identified phenologically how this is the behavior of this invasive species. And we can map and we can show to other institutions how the invasive species is working on these areas of mangrove. Next, please. About the social dimension, we have I have tell you about the anthropic categories, and then we have anthropic index, which is this map. The red is more anthropized areas, and the green is the less one. So we have several categories like roads, tracks, country roads, industrial areas, material ponds, infrastructure from tourism, rural and urban touristic areas, dams, or other artificial body waters and building areas. So this index can show you how the human impact is working in certain areas of the mangroves. Next, please. And also, we have some studies about how the hurricanes or storms or flooded is affecting the mangrove. So we analyze the data. We go to the field and check how the mangroves are losing, and with some flights with drone or with lidar and with some data field, we are checking how the resilience or restoration the mangroves are working across the time. Next, please. About the same component characterization, we have blue carbon accumulation rates. So we were going to the field and make these plot samples, and we get soil data samples for blue carbon content. We also have measures about forest structure data, and also flights with LiDAR to see the biomass, aerial above ground biomass, but also we have a map with below ground blue carbon biomass. I'm sorry, blue carbon. And all this information works for decision making and to public policies and also to mangrove restoration. Next, please. So we have continuous monitoring, not with other tools. These tools could be like a time series analysis. We have the greenness trends about the ecosystem. We can see the graphic below from January 2021 to January 2025, and how the mangrove of the greenness of the mangrove is losing in certain areas. So this vegetation greenness trend is from in the upper left right image is 2020 to 2024. In below we can see the RGB color, how the mangrove were loose until March in 2023. So another tool, next please. It's like a visor of the restoration areas. We upload like a geoserver with these mosaics of drone flights, and periodically we upload the imagery so you can see how the mangrove it's growing, or how the mangrove is the behavior of the restoration across the time and the space in these small plots. Next, please. We're also working in the same subject of mangrove restoration, working in a guide of how we can monitor the areas of restoration with a special. It's okay. With a special focus in the spatial about the imagery of flight drones, how we can monitor the restoration areas. We will get coming soon, this publication. Next, please. And we also have in Conavio the SNIRRA, which is a national system of with information for the environmental restoration. So it compiles the information, communicates, and contributes to the whole population, from scientists to students, and we can trace, or it could be very traceability, the information in this mangrove section. So we are collaborating with other institutions in Mexico, like CONAFOR, which is the Forest Commission, with some restoration mangrove calls to get the information. And we also have this platform. Next, please. And as I tell you, the mangrove monitoring system has the online repository with this whole information. We have web page with the whole publications, geoportal. You can download the whole maps, and we also have Atlas of Nature and Society, which is interactive. You can see how the dynamic or losses or gainings in the mangrove across the time. So we also have an application, which is the virtual reality. So you can use to get inside the mangroves and navigate across the mangroves, see the biodiversity inside the mangroves. And next one. So we think that in this context, we can offer or provide some information in order to reach the NDC goals, like provide mangrove extension in certain scale and in certain accuracy, and provide information about the status of conservation, greenness trends by 2 seasons by years, for example, and provide obviously the distribution and support the national 2.3 of the National Biodiversity Strategy in Mexico by 2030 to restore between the 30 and 50% of the marine coastal degraded ecosystems. So this system could make the spatial monitoring in restoration areas in order to verify the status or the progress of the restoration efforts. So what do we need? Maybe it's strength the mangrove monitoring system with more staff and computing processing and computer equipment. Maybe it's that what we need, probably. Next. And thanks. That's all. In the public, it's my partner, Maria Teresa, and me, if you have some questions at the end. Thank you. Thank you very much.
Het is jammer voor de organisatie. Is het allemaal best wel...
Thank you so much, Edgar. It's inspiring to hear how Mexico's mangrove monitoring systems is not only generating high-quality national data, but it's also helping shape tangible targets within Mexico's NDC. Your insights into coordination highlight just how important as well long-term investments are in monitoring capacity really is. Next, we head to Panama to learn about their data-driven approach to mangrove conservation within their national climate strategy. Joining us is Jorge Jian from the Ministry of the Environment's Coast and Marine Division, who will speak to how Panama has shaped its mangrove NDC targets using data and monitoring insights. Jorge, over to you. Thank you so much.
Hi, good morning, everyone. My name is Jorge Jian. I also part of the team of Ministry of Environment. I just to mention that my presentation is Spanish, but I try to speak in English. If I feel I lose something, just I apologize. Please, the next slide. Well, I have to explain about the new phase of NDC Panama had especially on the marine sector ecosystem. Next. Well, now Panama are challenged in the next phase of the NDC. These are all the sectors that we have commitments. In my case, I have to be on the front line to encourage to accomplish the marine coastal sector commitments. Please, the next. Well, we have in this phase almost 6 commitments related with the marine sector. The first that we have on hands is to try to create more protected areas, including the mangroves sector. Also, we have to, on the 2027, try to get a monitor, evaluate the status of the mangrove to understand that the management that we are doing is enough or not. The next is in 2028 to monitoring the sea turtles, maybe because Panama is a coastal country, we are lost too many of the coast. We are also have the situation that one of the indigenous sectors that live on the island have to move it to the mainland. Also, that's involved that we are losing species that are the important part of the life of the turtle, because if we continue to lose species, we have to lower the population of the sea turtle, that we have to monitor and protect and make more effort to take care of these species. The other community habit, we have to actualize, update our national wetland inventory. That involves the mangrove, involves also other type of wetland, not just the marine coastal, but we have to do the part of the marine sector to have where we have the coral, where we have the seagrass, etc. The next slide, please. Something that we also are ongoing, maybe these a few months, we have to make sure that we accomplish, is to have an action plan direct to management the marine ecosystem, preventing the action or the impact that we are affronting from the climate change. On 2027, we have proposing to mapping all the seagrass and the corals in our coast, because that's type ecosystem are very important, and especially in the marine seagrass have the capacity to stack carbon. On 2028, we expecting to reforestate restoration almost 1,800 hectares of mangroves. That's the big challenge that we have to accomplish on 2028 from the mangroves. Please, the next. Well, Panama also consider that we have huge biodiversity on the mangrove. That's why it's one of the iconic ecosystems that we chose to include on the NDCs. Especially because even that are the same species in the coast of the Caribbean and the coast in the Pacific side, his behavior is different. The season they produce seeds, etc., is not the same. And that's why we have to have more study to comprehend his capacity to stock the carbon. Recently, Panama have, with Colombia, discovered another species on mangle piñuelo, the Peliceria ventani. Is with the rose in pink, that just we have to understand that are different with the other species that normally was the name Peliceria rhizophora. For Panama, we also consider some species or associate species part of the mangrove because they are related, they're interrelated, especially in the Caribbean side. Sometimes we have the mangrove, even with the coral, even with the seagrass in 5 meters. It is something very particular. Besides, in the Pacific side, that you see the bottom, it's more fluid. And now on this sector of the coast of Panama, is more common to see the difference between the front line of the red mangrove after the white and beside the black mangrove. that's one of the difference between the coast that Panama have on the mangrove. The next, please. As you know, the mangrove have the capacity almost 5 times to stock the carbon in soils compared with other type of woods in the mainland. Also with the marisma and the seagrass, but we are focused here on Panama to include the mangrove because we have more capacity and experience to monitor and know the place in the surface that we have it. Next, please. The next. Especially about the include the surface of mangrove. Now we have around 40%. We expect in the few years reach the almost the half of the all surface of mangrove in the system of protected areas, and also to create a system to monitoring its quality, its status. That's one of the challenges that we have to facing very soon. The next. About the surface, well, for the moment, we are evaluating the population near besides the mangrove to know where is the stakeholder that we have it. Some places in Panama have a private owner because those land was created before Panama formally exists, so are lands very, very old. And some person have or some organization have a private sector fund. This is few cases we have to evaluate where exactly are. And we also have a compare study for Providence to see how the changes of the mangrove between the last map that we have it and the ongoing map that we have today. But the expectations are to create this huge number. Sorry if I missed the number, but we have to find the places, but depends just determining the potential sector that we have it, the quantity of resources that we can achieve, and we may start from some places the project, but we still have to push more sectors because the challenge is complicated to achieve in the time that we have it on hands. Next, please. For the moment, we have detected around 1,000 hectares for the moment. The potential sector that we have to convert or to reforestation on mangroves. But this is the easy part of the challenge because it's not just I detected, we have the places. We have to evaluate how are the status, how are degraded, what are the techniques that we have to use, and how we cost. And if I have or evaluated, if I have enough resources on human and financial to accomplish. Just detected is the first step, but we have to evaluate all these varieties to precise or have the best success on invest the resources that we have it. That's to evaluate if a place is too rich to find it, is too difficult to get there, if there are two risks or others activities they can put in risk the investment we have it. And that's the risk we have to evaluate to at the end decide what is the place that we have to invest first. That's the idea we have it to accomplish this. How we do it? Please, the next. We also to try to be part of the Mangrove Alliance or Capital Panama recently evaluate. I hope so in the next month, 2 or 3, we also find it. We try to find other allies like the Mangrove Alliance Climate because we know that we require some assistance. We did the first time, we first step to create our manual. We have also our internal manual to provide the technical resource or a professional to how to do it, because the mangrove I mentioned in the Caribbean is different, even the same the species on the Pacific, and the technique that we have to invest depends of that how they are degraded and what are the capacity on resource and human on finance to from the sector that we have lost the mangrove. Please, the next. Well, I mentioned also this manual help us to what are the varieties that we have to evaluate, just not the biological characteristic, the hydrologic, and how the soils component, because that's the only way that we can see if our invests are fine or we have to change the technique that we're using on each place, because in each sector we'll have different impacts that we have to adapt the different techniques that we require to understand if we are a success almost that 70% of survival of the seed that we plant. And we have to monitor around 5 years. After 5 years, we feel that the mangrove can go by herself. The next. The next step that we are doing is also evaluate all the commitments that Panama have in front of these old conventions. Because after too many years, we have different language or different targets in that even seems inconsistent. And now we are trying to combine them and try to find the partners to have same targets, because we are the same in the minister. Even we have the 3 focal points where we have to work together because the resources are limited and the team is the same. That's something that we are now facing to accomplish all the commitment that Panama have on hands. Next. Well, I feel that the question will be at the end, but that's all. Thanks for the time you give me.
Thank you so much, Jorge. Your overview of Panama's NDC process shows how targeted data on mangrove extent and restoration potential can drive incredibly bold commitments. It's clear that Panama is leading by example in embedding ecosystem services into climate planning. So with these country experiences in mind, let's now turn to the data platforms themselves, starting with one of the most widely used amongst the Global Mangrove Alliance. It's the Global Mangrove Watch. So with that, we're going to transition to Lamart Hilargis from the Wetlands International team and also a steerco organization to the Global Mangrove Alliance. And with that, we're going to hand it over to Lamart, who's also going to give us a live demonstration of the Global Mangrove Watch. Lamart, over to you, and thank you so much.
Thank you so much, Christina. Just checking if everyone can see the screen. Yeah, excellent. Just very quickly, my name is Lamart Hilargis. I'm a Senior Technical Officer for Wetlands International. I work on the mapping and monitoring of wetlands, more specifically mangroves. And I'm going to give you a lightning speed introduction of the Global Mangrove Watch platform, but focused on how it can support the NDC process. So I'll do a quick live demo of the platform and show you some relevant data sets and how they can contribute. And I know live demos can be a bit risky, but I was willing to take the risk because if it works, it's a much better demo than a set of static slides could be. So Global Mangrove Watch provides data about mangroves, not strictly mangroves, but things that are relevant to mangroves at the global, national and local scale. The nationally determined contributions, of course, are relevant at the country level, and therefore for this demonstration, I will use the country of Mozambique as an example, but most of the data is available for every country that has mangroves. Now, roughly, Global Mangrove Watch can be used to support the NDC process in 3 different ways. So it can be used to set targets, to support implementation, and also to do reporting. And we have data layers that are relevant both for mitigation interventions as well as adaptation to climate change. Just a very quick introduction to the user interface. Most of the screen is a map, and on the left-hand side of the screen you will find what we call widgets. They're just summaries of what you're looking at on the map. Then a few things that are relevant is we have this widgets deck that we call it, where you can switch on and off all the different layers as well as widgets. So for example, now I think just the mangrove habitat extent is relevant, and I just have this single widget on the left-hand side. And you'll see in this widget there's a download button. So all the data we produce ourselves is available under an open license that can be used for your own analysis as well. There's some information about how these layers were produced, and you can switch on and off the layers. And let's zoom into to Mozambique. And maybe to make it a bit prettier, let's go and use a satellite background. And here in this teal blue color, you see where mangroves are in Mozambique. Now, it's important to see the status of mangroves in these international policy frameworks. So let's have a look for Mozambique. In the second widget, mangrove international status. On the NDCs, it says there's a target of reducing emissions by 40 megatons of CO2 equivalents between 2020 and 2025. And we pull that data just directly from Global Climate Watch, because they collect all that data in a very structured way already. There's also information in the NDCs of Mozambique relating to adaptation that is not available directly through Climate Watch yet in this same structured way, but Mozambique's NDC includes regeneration of mangroves as part of a goal to build resilience of fisheries. So I'll show you something about that. And it set a target to expand restored mangroves to 5,000 hectares by 2025 to build fishery resilience, and also on coastal protection. So when setting these targets, I'll just switch off everything that's not relevant to keep a good overview. On the fisheries, we have this layer, and here you see in the purple shades the areas that are more intensely fished than the lighter colored, the yellow, light orange shades. So this could help you prioritize where to restore these mangroves. And on the coastal protection side, this is data that is only available at the country level, but they're interesting statistics. So they provide insight into the area that mangroves are expected to protect during storms that could occur annually, or once every 25 years, or once every 100 years. And you can switch between these different scenarios. And you can switch also between different layers that show you the area protected, or the number of people protected, or stock that is protected, expressed in US dollars, and switch between these scenarios. Ultimately, NDC-related interventions revolve around mangrove conservation and mangrove restoration. And on the conservation side, the following layers are important. So we have the mangrove extent that I showed earlier, which just shows you where the mangroves are in your country. So where do you find mangroves? Then we have one layer that has information about the carbon, both in the biomass and in the soil of these mangrove ecosystems. So here, especially if you zoom in, you see the darker brown colored areas have higher carbon stocks than the lighter colored areas. And also you could look at which areas are already protected or not. And I realize on a satellite background, it doesn't show us clearly, but if we move back to the white background, you see these blue areas are protected areas, and outside of that is not protected yet. Currently, this is only strictly protected areas, so it doesn't include OECMs yet. It will be added in the near future. So now let's go back to Mozambique's specific target of restoring 5,000 hectares of mangroves, or increasing the restored area to that 5,000 hectares. Global Mangrove Watch can be used to identify and prioritize these restoration areas. So first, let's have a look to why mangroves are so important in carbon sequestration. We have the emissions mitigation widget, and this basically shows you on the left-hand side the potential for emission mitigation of mangrove-related interventions, and on the right-hand side, other ecosystems. Obviously, peatlands are still number one in this context, but compared to, for example, forest and grassland-related interventions, mangroves have significantly more potential on a per hectare basis. Now let's have a look at areas that have been lost. Those are the areas that you will find in red here, so especially these coastal fringes, heavy eroded, because you can't really restore areas of mangroves where there never were any mangroves in the first place. So it's important to know where mangroves have been lost. And also you can see in Mozambique, a total area of almost 16,000 hectares was lost between 1996 and 2020. So that target area of 5,000 hectares seems to be quite realistic and sort of represents a 30% of the total area lost. Then one thing, these red areas is the loss until the year 2020. So in our current data set, the time series stops in 2020. But by adding a second data set on mangrove alerts, we can actually look at areas of more recent loss. So this is where mangrove areas were lost since 2020. And I can just quickly give you one example here in the Zambezi Delta, where, let's go back to 2020, and I'll hide the alerts. And it looked quite green and healthy. And if we go to a recent date, you see there's quite some dieback. It's just 200, 300 hectares of dieback it's probably due to damming and hydrological disturbance here at the beach. My final widget I wanted to show you, I'll zoom out a little bit, is on the restoration potential. So with this layer, we stop looking at the pixel level, but we start looking at typological units, so larger areas of mangroves, and aggregating the statistics there. So how much mangrove was lost, what was the driver of loss, what's the biophysical potential for restoring mangroves in those areas. So, for example, here you see the type is it's an estuary. The maximum mangrove area is just under 11,000 hectares. We lost 2,000 of that, and we consider around 1,000 hectares to be restorable. So this could be an area that significantly contributes to that NDC target of 5,000 hectares. And on a scale of 0 to 100, it has a biophysical score of 94, so relatively high potential for restoration in this area. And if you want to look into the details, you can look here and also in the publications listed here. So I realized this was a really fast lightning introduction of the Global Mangrove Watch, but I hope I've shown you that there's a lot of relevant data sets on there that can be usable in your context as well. A few frequently asked questions that maybe I'd like to answer now is the Global Mangrove Watch is a globally consistent data set. So what we call mangroves is globally consistent. And we realize that differs with national maps sometimes because they align much more logically to national level policy frameworks and definitions. And when possible, therefore, we show these side by side. So if data licenses and sharing agreements allow for it, we can show national level maps side by side to the Global Mangrove Watch layers. And in that sense, I think they're very complementary also to the monitoring systems demonstrated earlier by Panama and Mexico. Finally, we're working on an update of our maps that will increase the period we cover from 1990 till 2024 and significantly improve the accuracy in locations that we identified since releasing the last version in 2022, based on lots and lots of user feedback. And finally, we will be scaling the mangrove loss alerts to a global level by the end of this year. Thank you very much for your attention.
Thank you so much, Lamart. The demonstration really brings home the power of near real-time mapping and spatial analysis, and not just to monitor change, but to inform where and how to act. And it's great to hear how the Global Mangrove Watch can be a complement to national monitoring systems. Let's now explore how scientific research is helping fill the gaps in ecosystem-level data, especially on carbon stocks and blue carbon potential. So with that, we now hand it over to Annie Tamaraval, to go over the role of research for mangrove data and to do a deep dive on the Coastal Carbon Atlas, a Smithsonian Institution resource. So with that, Annie, the floor is yours. Thank you so much.
Great, thanks so much. Yes, hi everyone, I'm Annie Tamaraval, and today I'm giving this presentation on behalf of my supervisor, who's Dr. Steve Canty, and my colleague, Dr. Hannah Morissette, who provided a lot of these beautiful images for the slides. A lot of this work comes from their hard work over the last decade or so, and a lot of different partners. So this is work that we're doing actively within the Marine Conservation Lab at the Smithsonian Environmental Research Center, but this also is attributed to a lot of partner contributions, including Pew. So next slide, please. The Marine Conservation Lab here at CERC is really focused, we focus on blue carbon, but we also do more than just blue carbon. We think about conservation as it relates to a seascape. So we have a lot of different researchers from all over the world developing really wonderful technical expertise about how coastal environments react, how they go together, and we try to provide technical expertise for countries that want to include coastal wetlands into their NDCs and different things like that. So when we're brought to the table as the technical experts, and I feel like Jorge sort of mentioned this in his case study of Panama, that we can provide some of that technical capacity, not to lead projects, but to simply support, to catalyze, to help bring people together and to provide that technical expertise to make sure that we have that capacity as we move forward with NDCs. So with that in mind, we always think about our projects by in-country partner needs. And so this is a figure that was made by my colleague Hannah for a paper that's in submission right now, that we take our academic kind of technical expertise knowledge, we make sure that we bring a lot of people to the table. So we're sharing that knowledge along with local ecosystem knowledge, traditional ecosystem knowledge. We combine that together. And that's a very iterative and adaptive process that can create a plan that makes sense in country and also can make sure that we have sustainable efforts moving forward. So realistically, that kind of iterative, very partner-based collaborative effort leads to effective policy and management for coastal conservation. And it has been such a delight to sort of come from my very technical background of being a sediment expert, loving biogeochemistry, but making sure that we take those technical capacities that we all gain in our science and actually put it forward to meaningful community-based, country-based change and policy. So next slide. So how this actually works, you can click through here. We have partnerships with 3 countries that I'd like to highlight today. So Belize, Honduras, and Panama. I think if you click the last one, yeah. And so each of these countries were at different kind of places in their ambitions when they brought us to the table and started partnerships with us in this process. And I think it's been really telling because my supervisor, Steve, once expressed that he wished we could have a camera crew kind of go around with us as we develop the plans and ambitions for these NDCs, because in some ways it's chaos. You're going back and forth and you're doing lots of iterations. You're bringing lots of people to the table because you want to make sure that you have a comprehensive approach to actually make plans that can have meaningful change. So for example, Belize needed field analysis. We needed to do a lot of field work and capacity building in country to make sure that we had a really good baseline to develop the first national mangrove carbon baseline for the country. So that included a lot of trainings, a lot of in-country field work expeditions with lots of different partners, including other NGOs, partner foundations, government partners, and also university partners that all help to make that happen. In Honduras, we needed data collection and an inclusion of, there's this big interest to include the wider importance, not only about coastal wetlands as it relates to blue carbon and that inclusion in NDCs, but also what does it mean for fisheries? And in Panama, we sort of divide our work into 2 phases. So in phase 1, there was lots of data actually already available for Panama, but we needed collation of that data. What do we actually do with that data to get it to a certain tier of reporting that could be useful in NDCs? And another telling thing is that when you actually bring scientists in country to the table together, there's always a lot more data than one can find online or expect. So this is another really good example of how coming together as a group, as a collaborative effort, actually allows these projects to move more efficiently and effectively going forward. So phase 1 for Panama included a lot of collation of data, a little bit of field experience, which included a capacity building workshop that I got to be a part of. That phase is actually over. Last week, there was a presentation, I think that was led by Pew, that actually presented that data to the government. And now phase 2 might be starting, which will actually go beyond mangroves and include seagrasses for a field and data collection campaign for that next step. So next slide. So thinking about all the data and data collation and what that actually means, this is the kind of broadcast of one of my favorite tools that the Smithsonian provides, which is the Coastal Carbon Atlas. So there's a QR code at the top of this slide. You can click that and go to the interactive tool. I'm maybe not as brave to show a live demo of this tool, but I'm very available after if anybody wants to look at this a little bit more. So this is the Coastal Carbon Atlas. Basically, it provides open source coastal carbon data. Right now, it's really focused on soil organic carbon in coastal ecosystems globally. There's over 16,000 records in the database right now. We work very carefully to ensure that the partners that give us data feel included, represented. We get their data, we put it into a very, very organized format that can then be used for different researchers, policymakers, anyone that would like to interact with this database moving forward. So this includes marshes, mangroves, seagrasses, and some smaller scale blue carbon ecosystems. So this is a global database. There's about 5,000 mangrove cores. You can click again. Then we can kind of break it down by how granular this data can go. You can click through 3 more times. So this is a case study of Belize. On this leftmost panel, we have Belize at a country level and broken into regions and where we have different records. So for example, in this sort of southern part of Belize, we have 86 mangrove soil organic carbon records. When we go into an ecosystem scale, so this riverine ecosystem to the south, we have 12 records. We can go to a site scale on this panel to the right, that we have 6 records on this particular kind of piece of land that's there. And we can actually get to a core by core scale. And this is really important because we can use how data availability can actually impact NDCs and that tier reporting that a country can get to. And so as different countries are looking to include coastal wetlands into their NDCs, you can use this also as a tool to see how countries actually, how many records did they include to actually get to that capacity building. So this data is all available on the Coastal Carbon Atlas and accessible to all. Next slide. The shaping of NDCs obviously come with ambitions and bringing people to the table, making sure that that group is diverse, that represents in-country partnerships, represents what in-country needs might be. That's really built on trust and begins in that iterative process. We also ensure that our technical capacity isn't just top down, but it actually includes different types of knowledge sharing, training, capacity building in country that includes the data management and collation piece. How do we get data from the Coastal Carbon Atlas? How do we include it in and upload it to it eventually? How we actually take a mangrove core, how we process this, and we try to keep in touch through every sort of aspect of that process from start to finish to make sure that our partners feel supported, how they feel empowered potentially by this technical capacity that we can bring in, and how that can move forward without us after kind of the goals have been met. And so that includes a continued pipeline. So a picture on the bottom right is where we had some of our Belize colleagues actually come to Smithsonian, learn specific lab techniques that we weren't able to learn in the field together. And a lot of those students now are working in capacity in country and continuing to improve and include different blue carbon quantifications within their country's needs. So this allows us to move beyond ambitions, but actually get to science-based protection and restoration targets. Next slide. So these lasting partnerships can actually lead to better implementations and long-term sustained efforts. So ideally, after we build that technical capacity, we get coastal wetlands into NDCs, then monitoring and evaluation can happen. We think about different factors like community investment and social ecological support. So I included 2 references to papers that are really including that social component piece of how important it is to engage communities in these restoration mitigation efforts. Grimm et al. 2024 and 2025, and Sarah Bonilla et al. 2025 includes not only in mangrove restoration work, but also in marine protected area work. And this helps us go forward into adaptive management. Next slide. So it's been an absolute treat to be able to learn this style of science from the Marine Conservation Lab at Smithsonian. I'm so happy to be a part of it. If you'd like to learn any more, we have social medias. My email is up there. These QR codes also lead to story maps that an intern for us had built last summer that shows our capacity, where we're working kind of globally, and how we break our efforts into blue carbon quantification, marine protected area work, and also these social frameworks. You can follow those QR codes. Maybe there's one more click, or maybe yeah, there's our little descriptors of that. So yes, that's what's happening currently right now at Smithsonian. I would be happy to answer any questions in our QA period.
Thank you so much, Annie. Your presentation highlights how on-the-ground science, particularly when done with collaboration with local partners, can powerfully support national-level commitments. The Coastal Carbon Atlas is clearly a very critical bridge between field data and policy action. So now we turn it to the IPCC wetlands guidance and a short introduction on how countries can estimate the carbon balance of their climate action on mangroves. So with that, we're going to turn it over to Matthew Warren, Forestry Officer on High Carbon Ecosystems, Peatlands, and Mangroves from the Food and Agriculture Organization of the United Nations. Matthew, thank you so much, and over to you.
Thank you so much, Christina, and thank you for the thanks to the NDC task force and to the Mangrove Breakthrough for inviting me to participate in this webinar, and thank you all for joining us today. You know, the Mangrove Breakthrough has just been so impressive with the impact that it's making on mangrove conservation and management throughout the world. So it's an honor to be here today. I'm just going to give a very brief overview of the IPCC Wetland Supplement, the section that's relevant for mangroves. We don't have enough time to go into really a lot of detail, so we're just going to kind of you know, provide an overview and talk a bit about what the supplement is and how it can be useful, and then of course how we can move beyond the supplement to really produce the best greenhouse gas inventory information from mangroves. So the 2013 IPCC Wetlands Supplement is actually a supplement document to the 2006 IPCC Guidelines for National Greenhouse Gas Inventories. So this is a good practice guide on how to develop greenhouse gas inventories for the land use change, and forestry sector. And in 2006, when the document was published, there was a general recognition that wetlands, and in particular organic soils, were really not given the treatment that was needed, given the very high capacity for organic soils and wetlands to produce, you know, to become major greenhouse gas emitters with land use change. So through a fairly formal, complicated process, the development of the supplement happened, so that we have now a whole 7 chapters dedicated to greenhouse gas inventories for wetlands. And so of course we have chapters 1 through 7. Chapter 2 treats drained peat soils or drained inland organic soils. We have rewetted organic soils, and then Chapter 4 is coastal wetlands. So that could be tidal marshes, mangroves, seagrasses, all of the coastal wetland. Well, it applies to coastal wetland ecosystems. And then we have, of course, inland wetland organic soils, constructed wetlands for wastewater, and then some cross-cutting issues. So again, it provides guidance on estimating and reporting anthropogenic greenhouse gas emissions and removals from managed coastal wetlands. Next slide, please. So this is just kind of like the basics. The first thing, really, once a country really acknowledges the importance of including coastal wetlands in climate commitments, not only NDCs, but also national adaptation plans and national biodiversity strategies and action plans. When we have this recognition to really include wetlands and coastal wetlands into these commitments and into these processes, really the first step is to develop national definitions. So we need to know, what are we going to monitor? What are our if these ecosystems are included in the commitments, then we need to have them very well defined so we know how to monitor them moving forward. The next would be to identify the relevant land management activities. So it could include timber extraction, aquaculture. We saw some examples of that in the earlier presentations. So we need to look at, the definitions and then the main activities that are driving any kind of change in those systems. And then we calculate the emissions and removals using the methodologies that are provided in the wetland supplement. Next slide, please. So, of course, I'm sure many of you are familiar with this tiered approach. So really, this is just a structure that the IPCC developed to create a starting point. So we have this tier 1 is very simple first order approach. So that's using mainly global data sets. So the global, it could be the Global Mangrove Watch, as was presented earlier, with the what they call the tier 1 emission factors, which are global averages for mangroves. And this is really just to set a benchmark. So it provides countries with the opportunities to, once they acknowledge the importance of their wetlands in their NDCs or in their mangroves in their NDCs, they can develop a first sort of benchmark of, okay, this it would inform how the greenhouse gas emissions or changes in carbon stocks in these systems at a very, very coarse level. And then we move to tier 2, which is a national level. So this is great examples from Mexico and Panama moving to tier 2 approaches. It's a more accurate approach reliant on country data. That it requires, of course, more complexity. And I was also very pleased to see the emphasis on partnerships, because not only do we get more sort of higher levels of complexity with the data, it's also a higher level of complexity with the institutional frameworks and the partnerships and the involvement of different institutions that might have a stake in managing mangroves. So it also takes a higher level of coordination. And that would be even moving into the tier 3 approach, which is more regional, more landscape-based information. Next slide, please. So basically, the guidelines introduce a stock change approach or a flux difference approach. So that's just changes in carbon stocks over time or changes in carbon stocks from a land use change. And flux difference approach is just gains and losses. So quantifying carbon that's coming into the system, the carbon that's going out of the system to create, it's more of like a carbon balance approach to determine if carbon's being gained or lost in the system. Now, mangroves are so complex with their carbon cycling that really the stock change approach is what's been used so far. So it's just a change in carbon stock over time or with a disturbance. Next slide, please. So that it includes guidance and the tier 1 emission factors for CO2 for 3 carbon pools: biomass, dead organic matter, and soil organic carbon. And it provides emission factors for those 3 carbon pools for basically 3 different activities: forest management practices, and there's different categories of forest management; extraction, which would be conversion to aquaculture, for example; and then rewetting or restoration. And then there's also some data on methane and nitrous oxide emissions. So it includes these factors for these carbon pools and these different activities for tropical wet, tropical dry, and subtropical domains. Next slide, please. So what I wanted to mention here is that mangroves are super diverse, right? Like even, latitude and climate and geomorphic position can play a very big role on mangrove structure and carbon storage, and also disturbance and tidal influences. So we have a huge diversity of mangroves, both across the geographic distribution of mangroves throughout the world, but also at more local scales, just depending on their geomorphology, geomorphic position, and exposure to tides, frequency, duration, for example, and disturbances. Next slide, please. So we have to keep in mind, like the emission factors that are presented, I'm using this above ground biomass for an example. So these are average above ground biomass values that are in the IPCC guidelines. And we see this huge range. And so that's just to keep in mind that these are global averages. So at a site level, at a country level, you really have to acknowledge or be aware of, you could be below this average or way above this average, depending on where you are in that distribution of the global data set. Next slide, please. So the IPCC wetland supplement, it was mainly designed for first order UNFCCC reporting. And not necessarily, it wasn't really designed for voluntary carbon markets. So for that, we need to really move towards a higher tier levels and more detailed carbon inventories at national and subnational and even landscape level scales. It's also 10 years old now. So there's been a lot of science that's been done since then. And, having high integrity emissions or reductions can really is what's needed to attract the climate finance. And so I'm great to see, the national mangrove inventories and assessments and where those are going to support monitoring for NDCs. Next slide, please. So just a quick example from Indonesia. Indonesia included mangroves in their national FREL using very detailed monitoring, a mangrove forest assessment or national mangrove inventory for activity data, and then applying IPCC Tier 1 emission factors to estimate emissions. So this is really the first step. This is how the IPCC wetland supplement was intended to be used. This was the first step, and then the next step is to refine emission factors to Tier 2 levels. Next slide, please. So the research is continuing. Here are two examples from that from Daniel Mariarso's group, Daniel Mariarso and his co-authors, who are also, many of these co-authors are also authors of the FREL, the Forest Reference Emission Levels for mangroves in Indonesia. So it's likely that these data will then, be integrated into the next version to approach more of a Tier 2 level. Next slide, please. So that's all I have for you today, and thank you so much. Happy to answer any questions with the time that we have remaining. Thank you.
Thank you, Matthew. Your overview of the IPCC wetland supplement and its application to mangrove frameworks really underscores how technical frameworks can help countries credibly and consistently account for their climate benefits of these ecosystems. It's encouraging also to see how global tools are being aligned with national and local efforts. So with that, we're going to turn to our closing remarks to have some final reflections and hear next steps. So I'm pleased to welcome Luce Gill, who's the Ocean and Climate Advisor to the Nature Conservancy, to give us some closing remarks and some final reflections. Luce, over to you. Thank you so much.
Thank you, Christina, and thank you everyone for joining us today for this third session in the Mangrove Breakthrough NDC Taskforce webinar series. Over the past hour, we've heard about how robust science-based data platforms like the Global Mangrove Watch, national monitoring systems, the IPCC wetland supplement, and tools like the Coastal Carbon Atlas are not just tools for measurement, they are enablers of action. They offer governments and stakeholders the clarity and confidence needed to set more ambitious, credible, and implementable targets in their NDCs and related strategies. From Mexico and Panama, we saw how countries are already drawing on these tools to identify gaps, strengthen national reporting, and build integrated approaches that respond both to climate and biodiversity needs. Their examples remind us that data is not just about numbers, it's about power. The power to plan better, to prioritize more effectively, and to bring communities, especially those on the front lines, into the center of policy and investment decisions. Also, during this webinar, we heard about the challenges, from fragmented data sources to limitations in existing inventories to the need for more consistent collaboration across scales. These gaps are real, and they underscore the importance of continuing to build partnerships, share knowledge, and invest in national capacity. As we move towards the next round of NDC updates and into the global stocktake implementation phase, it is clear that mangroves must be seen not as an option, but as an essential. They are essential for adaptation, they are essential for mitigation, and also essential for building resilient coastal economies and ecosystems. Today's session is just one part of that journey. As the Mangrove Breakthrough NDC Task Force, we are committed to supporting governments with the science, the tools, and the collaborative spaces that they need to turn ambition into action. Before we close, I wanted to also thank all of our speakers for sharing your insights, your experiences, and the critical work you're doing on the ground and in the policy arena. Also, thank you to all of you that joined today to this webinar, for asking your questions that we'll be sure to answering them, and for staying engaged in this webinar. Also, we wanted to invite all of you to stay in touch as we continue to build this global community of action. If your organization or government is interested in joining the Mangrove Breakthrough, please feel free to reach out to me, to Christina, or to anyone in the Mangrove Breakthrough Hub team, so we can guide you on how you can join this global community of action. And also, if you're interested in learning more about the Mangrove Breakthrough NDC Task Force and the support and the technical support we can give you to your government to include mangroves in your NDC, please feel free to reach out to us. Thank you all, and see you at the next session. And I'll pass it on to Christina.
Thank you so much, Luz, for those closing thoughts. Your message really brings us back full circle, reminding us that access to the right data is not just a technical challenge, but it's a strategic opportunity to raise both ambition and impact. So with that, let's open the floor to questions, but being aware of time, we only have time, unfortunately, for one question. But I do want to assure partners on the webinar call now that we have recorded all the questions asked, and we will be sending it to the panelists to follow up via email. So we'll be giving written responses to all the other questions in the email response follow-up. So apologies for that, but thank you all so much for your questions. We have time for one. And I will pass it to let's have one question on the Global Mangrove Watch. So Kate, if you don't mind answering, Kate from the Global Mangrove Alliance, an anonymous attendee said that it's great to see information regarding the importance for fish and food security, as well as other adaptation-related information on the Global Mangrove Watch. What other adaptation-related information are participants gathering to advance the climate commitments? So Kate, if you're on the call, over to you to answer that. And again, for all other questions, we are storing them and we'll be responding via written email. Thank you.
Yeah, thanks for that. And I'm worried that I'm not going to be able to give a fully comprehensive answer, as I think some of this is geared towards other participants on the call, but I can just say that some of the other data sets that we'll be bringing into Global Mangrove Watch in the near future that have to address this is we do have another upcoming data set that expands upon some of the data we have about coastal protection and expands it not only to include the coastal protection power of mangroves, but also other coastal wetlands. And the questioner also talked about fish. And so I'll just say that we also have another incoming data set to Global Mangrove Watch around not just where fishers are relying on mangroves, but also where mangroves are providing more enhancement values. So to specific types of fish and also invertebrates. And so that is also coming down the pike. But if others have things they want to chime in on in the chat, I'd be eager to hear them.
Or perhaps we can squeeze in one question to one of the country case studies. It's to either Jorge and or Edgar. An anonymous attendee says they were happy to learn that Panama monitors its mangrove coverage as part of its climate change adaptation monitoring efforts. Could you share any lessons learned from these monitoring and or reporting efforts? And thank you for the presentation.
Okay, we also have to create the action plan for monitoring in the mangrove. But we have the basis to do it. The only things that we almost experience we have two difference have the sector of the Caribbean and the Pacific. We also have maybe the same methodology, but we expect different results. because even they have the same species, the behavior, the timeline they reproduce, the quality of the morphology soils is different. Then it's necessary for us to have a better comprehension, the quality, the quantity of the capacity to stock the carbon in both sides, even they have the same species. That's something that we have to achievement or prove it with the continuum monitoring to have the knowledge of the species and how the capacity on the be right hand to affront the climate change that we have on hands today.
Thank you so much. And Edgar, I don't know if you wanted to speak to sharing any lessons learned from these monitoring and or reporting efforts from Mexico's perspective.
Yes. For Mexico, for example, specifically, the question is about the climate change. We have this invasive species, which is not invasive, it's a local species that has a behavior of invasive species because of climate change. So we identify this creeper when the rain is low and the temperature is high, the behavior of the plant of this creeper, they are changing. So it is important in these monitoring reports to include or to monitor several areas where we identify these invasive species. So this invasive species is very hard to remove because it has to be mechanical, or recently some people in the natural protected area discovered that with salty water, sprayed with salty water, the creeper can be dried, but it's a hard job to eliminate several thousand of hectares of this. So the lesson is that we have to monitor periodically and not stop with and maybe get some resources for the people who has the monitor tasks. And if you continue with this monitoring, you can identify this kind of impacts in the mangrove. And obviously, this information will be useful for the restoration. That's all. Thanks.
Thank you so much. And unfortunately, we are out of time today, so please continue to submit your questions in the chat. We'll be collecting them and we'll do our best to answer them via email. In other news, thank you all so much for your active engagement today, and a special thanks to our speakers for their deep expertise and inspiration that you've brought to this session. We've seen today that the data exist, the tools exist. What's needed now is clear: a bold, coordinated effort to integrate the science into NDCs, adaptation plans, and investment decisions that touch mangrove ecosystems. Whether you're a policymaker, practitioner, researcher, or investor, your next step matters. So use these tools, share them, build partnerships across ministries and sectors, and most importantly, translate this knowledge into policy. We hope today's session has helped you identify new tools and strategies to support the inclusion of mangrove data in NDCs and to strengthen national commitments through evidence-based policies. We encourage you to explore the Mangrove Breakthrough Data Resource Hub and best practices folder, which the QR code here will link you to. And this includes guidance on the Global Mangrove Watch, as well as the National Inventories and the Coastal Carbon Atlas. On behalf of the Mangrove Breakthrough NDC Taskforce, the Global Mangrove Alliance, and the High Level Climate Champions, thank you all so much for being part of this important conversation. We look forward to continuing this work with you together. Thank you all so much. And that concludes our third webinar series on opportunities for including mangrove data in NDCs. And once again, a huge thank you to our incredible speakers and panelists who brought great expertise and insights. Thank you all so much.